Welcome. I'm Alison Gowman, the chair of Livery Climate Action Group, and this is one of our regular meetings of the SPOCs, the single points of contact for the 107 members of the livery companies and other organisations. And as you know, the way of working this year is that we're actually having presenters rather than just having a free-for-all chat. And I'm really delighted today that we've got two SPOCs from two of our members who are going to be talking about their topics. They're not directly related, but as we were just sort of chatting about in the preamble, you know, there is so much wealth of knowledge and understanding that actually everything is interrelated, as we know, with climate matters. So we're great to welcome you all. So we're going to split it effectively into two halves. The first half is going to be David Bates, and the second half with Jonathan Louth. Both of them do have presentations on the screen. We hope will work.
Good evening, everybody. I'm speaking this evening to an architects company initiative. Built with People is in development with other maker and construction liveries, and it is about optimizing sustainable work practices and achieving commensurate energy reductions through combining technological developments with human and dexterous skills. I'm leading towards a case study in stonework and masonry, and shown here is a computer 3D model prepared by CAD-Plan Limited. The model is interrogatable and forms the basis for reconstructing lost material. And while the video is running through, I want to share some statistics. These suggest that every one of our disciplines has an urgent task to get the technology and the use of people right, and to do that quite soon. When my grandparents were born, there were 2 billion people on the earth. I was born 60 years later into a world of 2.5 billion, a growth of just 1/4. Another 60 years and we passed 7 billion, a growth of 2 3/4. And now, just 15 years later, we have 8.2 billion planetary compatriots, which is already 1/6 growth in half a generation. All these people need housing, feeding, clothing, heating, and medicating. And every person who does no physical work must be supplanted by a machine that also, after mining and manufacture, needs the industrial equivalent of housing, feeding, clothing, heating, and medicating. And meanwhile, because of machines and all the fuels, since 1992, we have added 2 parts per million of CO2 into the atmosphere every single year, except last year. Then we added 3 parts per million. Our underlying agenda is an ever more urgent global discussion about the impact on people and nations when integrating technology with traditional and modern crafts in the built environment. 50 years ago, we were surrounded by hand-built environments with places for many crafts, dexterous and tradespeople with manual arts and crafts skills. Machines are not new. Even the Tower of Babel presumably had timber cranes and iron tools. And though our modern tubing has a strength to weight ratio superiority over historical scaffolds, they were much the same as 6 centuries ago, scaled and proportioned as they must be to the dimensions of the human body. Modern materials also make for the chance to work all year round instead of stopping in the winter. Technological prowess today is not intrinsically good. Here at Winchester Cathedral roof, this extraordinary prefabricated temporary roofing structure frames sat on the ground for several intended days while engineers recalculated counterweights for the crane. Long before we started placing stones course upon course, someone had the idea of a lathe engine powered by foot pedal or the whip of a sapling. And the Trulli field huts in Calabria represent a manual tradition of construction dating back several thousand years, quarrying and rough working stone into dry stone walls. And in 1357, when the Judith Bridge in Prague was reconstructed in stone, this model in the Charles Bridge Museum shows a painstakingly logical sequence of construction. from driving piles and pumping water out to layering a roadway over the arches. The breathtaking sight in the bottom middle picture of vast medieval workshop barns, piled and stilted over the water, supported by a heartwarmingly familiar plethora of trades on the dry embankments, is all laid out in the museum's fine exhibit case. Conversely, in human-free construction, forecast in 2017 by the international infrastructure group Balfour Beatty, off-site components would arrive on driverless trucks, be assembled by robots, overseen for accuracy by GPS drones, and the remote control of machinery and new materials and techniques expects to improve cost, safety and efficiency. There is a place for that in the world. Many livery companies are at the forefront, makers in metallurgy, hardeners in plastics and the like. Looking at the clockmaker's art in Jean Nouvel's Paris facade, one can foresee how the Institut du Monde Arabe, built in the 1980s, might very well now be constructed in that manner. Thus, the call for integrating craft with technology is not a Luddite's call back to a manual economy. Ancient crafts all have their modern methods. But the advantages of technology and energy-intensive manufacture do not always trump the economic cycle. Government's own research into UK employment from 1861 to 2018 notes how the employment rate is in the long run affected by developments in educational attainment, wider economic policy and business cycles. Danube House in Prague's business district was made at a time when the Czech economy was far behind that of Germany or France. What looks like a building specified to be manufactured in the powerhouses of Western Europe, all the shiny metal details have not been computerized, unstamped or extruded from the base metal because the cost structure in Czechoslovakia far exceeded the budget, but forged and polished by hand they could be afforded. Recent research with Exeter University explored the role of digital fabrication compared with digital craft participation in improving the well-being, particularly for those from disadvantaged groups. Many studies have shown the positive value of creative craft sessions on mental health and well-being. The Bartlett School of Architecture's team for digital stone construction hopes to develop robotic random rubble wall construction and saving all manner of human risks and wear and tear and being able to build structures such as these trulli. Now, where would the mason's capacities be gained from apprentice to master, and who pays both the active machines and the passive people when the machines take over? At the entry to Stonecutter Street here in London, number 2 is announced by lettering designed and incised with computerized numerical control. There is no stone cutter here, and even an untrained eye will comprehend that these clergy memorials in Winchester Cathedral betray the human hand of the mason who made and the letterer who inscribed them, as do Tobias Kay's spectacularly refined sounding bowls, stringed and tuned to great effect with a significant penetration in marketing terms into music and occupational therapy. And in the largest of these, the centre of the sounding board is just 1/2 of a millimetre thick. It is the apprenticed and experienced maker's hand that senses the capacity of the material to be stretched to such limits of finesse. So the question arises, who programs the technological systems? Who runs the machines? Who selects materials and controls quality to match how a master produces complexity and delight, as in these fault stones at Władysław Hall in Prague? Apprentices must have traditional learning in techniques and materials. Technology must not supplant the base tasks which teach any apprentice their trade. Not everyone has the mindset to work with computer numerical controls. Much dignity of work and the well-being benefits derived from craft. At Aylesford Priory, this young lad, captivated not by the array of cakes, but by a hand-carved sculpture of an infant with a friar, indicates how handwork and natural products are of significance to the human mind. McKinsey's reckoned in 2017 that 10% of the global workforce may need to switch occupational categories. With AI, that 10% estimate may well be rising, and the graph shows employment share by sector from 1850 to 2015. As liveries, we have to focus on how our sectors can absorb able-bodied people and people of alternative abilities, as well as machines, because one can see in the big green mark how agriculture has dwindled entirely, whereas construction, transport, and what other activities have stayed relatively stable, and others have grown substantially. So which sectors could absorb our people? The overall employment rate in all sectors was about 76% in 1870 and again in 1955. It has hardly ever returned to those levels since automation and the fuel crises in the 1970s. Technology has created neither prosperity, nor wealth, nor health sufficient to offset its debilitating side effects. Feeding idle people, while also resourcing labour-saving technology, is unsustainable. Just consider the vaping devices in their CO2 and their waste output compared to the cigarettes they replace, and the factories required to make the vaping equipment being so much more technologically refined than the tobacco rolling factories of the past. The development and manufacture of technologies generate heat and they degrade increasingly scarce materials, but it is not a change which is making many of us happy. Dexterous work alleviates anxiety, depression, loneliness, even dementia. It heals the mind and creates pride. So I move on to the stone workshops at York Minster. First, their trials with exoskeletal personal lifting gear and air-powered tools. Then a new computer-controlled principal cutting shop. Now the master masons are mastering the technology. Their work moves from the cold scaffold to the warm workshops, deferring retirement and engaging longer with the apprentices of tomorrow. So dexterous capacities gained through apprenticeship journey right on to mastery of the materials. That enables analysis and oversight to make an effective manual survey and restorative intervention such as undertaken here at Hardwick Hall. At Cologne Cathedral, their digital scan of the entire buildings enables their trained masons to predict the future repairs for next summer without first erecting a survey scaffold this summer. I want to expand on these. Built with people, our ideas in Cologne and York, and it reports in a sense on the use of digital and modern technology in support of stonemasonry through a case study at Southwark St George's Roman Catholic Cathedral for integrating technology with traditional and modern crafts in the built environment. We see an original Pugin church opened in 1848 and then firebombed in 1941, and then from 1953 rebuilding under the architect Romilly Craze, and the significance of the study is the effect of fire and of a post-war roof system. Romilly Craze rebuilt all the brick parapets, but his mortars in the modern brickwork deteriorated significantly faster than the early 19th century mortars. The attention and the project funding that arose around these high-level defects allowed us to pay specific attention to the most holy and most decorative feature of Pugin's surviving exterior, namely a low-level parapet inscription on the Blessed Sacrament Chapel in the liturgical northeast corner. But it turned out to be heat damaged from the firebombing, and Craze had then backed that frieze with a concrete flat roof affecting the water and dampness. The inscription is a text from the Te Deum, Tibi cherubim et seraphim incessabili voce proclamant Sanctus, Sanctus, Sanctus. We knew there would be significant losses during conservation, consolidation, cleaning, and interpretation, and some of the carved inscription was eroded, other parts were fully intact as if carved recently, Some were intact with a pollutant crust of white calcium from the rain runoff or black crusted from sulfation layers. Yet some remain happily intact without anything more than surface carbonation forming a yellowish calcium oxalate. CAD-Plan undertook a 3D LiDAR scan of the inscription, resulting in a point cloud representation. Some 150 photographs were calibrated to the surface of the inscription, then mapped or pasted onto the model. That gave a 3D interrogatable record of the condition before conservation. The second step, involving technology, was some trials for cleaning the stonework. Spencer Hall and Sarah Makefield at Pay Stonework and Conservation introduced us to Martin Cooper of Linton Lasers Limited. Sarah surveyed and mapped the condition of the inscription with iPad photos and markup tools. Martin assessed a field trial for laser cleaning being non-percussive. And you'll see a little square appearing in the middle. The laser is gradually cleaning that tiny bit without touching the material. After the field trial, Sarah then tested several adjacent sections of surface using traditional wet water and chemical poultice techniques for comparison. None of these matched the capacity for the laser to remove the blackened and accreted pollutants without also removing material that might yet be saved. And so the laser system was employed throughout the valuable lettered inscription. The laser treatment exposed heat fractures in the inscription, which are best ascribed to heat from firebombing the war, shown on that L to the bottom left-hand picture. As an aside, I think one can safely surmise that the inscription had been entrusted to a master carver, or at least a highly experienced journeyman, whereas the floriated frieze was apparently delegated to more junior masons, perhaps even to some advanced apprentices. Small samples of lettering that came away during the cleaning could be sent for electron microscope analysis at WHD Microanalysis Consultants Limited. And Nick Winter's work there helped to identify the variation between black gypsum atmospheric reactions that are resistant to cleaning techniques as opposed to softer black petrochemical airborne grime that sits on the surface of the stone. And this technological data helped to identify the true original profile of the master mason's work. Some apparently clean sound letters were in fact entirely unattached to the string course, being held there by dust and grime that had permeated behind the letter. This U shown here actually fell away completely whole as I touched it, and such letters could not be saved in situ, but did serve to inform the reconstruction. Sarah and her colleagues worked over all the carving, mostly conserving, cleaning, and then protecting the inscription with a stippled mortar coating. And throughout that work, Sarah documented the carving on her iPad, logging before and after conditions and which technique was used where. And thereafter, in her studio, she was able to set out the whole inscription as it might have been. CAD-Plan returned and rescanned the entire carving, creating a second LiDAR scan with a point cloud and then a digital wire mesh model from which a reconstruction of the original inscription would be prepared. And where the original lettering had survived mostly intact, the 3D data of clean surfaces plus that salvaged letter U would prove useful to the computer artists John Jones and Brian Buxton at Viz 3D. I shall simplify and telescope the steps involved in forming a digital reconstruction of the inscription, in part because John and Brian at Viz 3D went through a vast number of iterations and I'm not certain of which digital file format preceded which other. Viz 3D first assembled the 3D data into a set of wireframe and surface maps from which they could establish the profile and the sectional run of the lettering and the substrate. The substrate included a transition from convex along the lettered corbel to concave behind the two stop-end return stones with the carved angels. And as both the artist and a computer renderer, John Jones could get his mind around the multiple data sources and into the mindset of the original stonemason. He consulted master carver Hugh Wedderburn about the nature of carving and how the undercut or serif or arises might have been approached. Sarah Mayfield advised on setting out and style of the lost Gothic script and its spacing to the crosses and the angel figures, which John then modelled in 3D CAD software. A technologist skilled in only data and software would not take that trouble. It was vital to engage the eye of a creative mind with the advice of a carver and a conservator. Several iterations of the lettering appeared, segment by segment, and John's work included recording the position of tight mortar joints between the original stones. Particular attention was paid to the angel figures at each end, and Sarah Mayfield, being a sculptor as well as a conservator, was able to add insight to those models, for which she had taken additional detailed photographs on the scaffold. For now, there is a set of original cobblestones in a functioning parapet, howsoever much eroded or weathered they are, and in due course the entire scheme will have to be taken down and recarved, and in doing so, learning also from pilot project at York Minster and in recreating a finial and in modelling a statue of the late Queen for the West Front, there are 6 steps integrating skillful people with leading technology, which we might talk about if we have time. But for sustainability, first, within our respective livery climate action roles, there is a message to take back and a part to be played, both in the built environment and in other sectors. We are none of us quite sure whether energy savings made with new technologies really do offset their embodied footprint during their lifespan. But we do know that every physical action undertaken by a human being makes an energy or CO2 saving compared with doing it by machine. I have set out some research and some statistics about this fundamental necessity. The necessity not to supplant people from the workplace, but to connect technology with people in productive work. And I've touched upon several pilot projects at York, Cologne and St George's, Southwark, which have played a part in generating our Built with People initiative. The initiative follows preliminary meetings with Alison Gowman, among others, and including Julie Emma McLaughlin, formerly the city's Director of Environment, and it draws together discussions with affiliates at the King's Foundation and York Minster, with some of the maker liveries and the Architects Company. And subsequent conversations indicate now is the right moment to engage on a broader footing to establish a profit-for-purpose entity that enables the developer and constructor sectors to derive benefit, sustainability, viability and safety from a workforce with dexterous skills, with experience of materials, with a route for lifelong and continuous retraining, for the workforce to be fully supported by technology and art. If we were going forward with the parapet project, the 3D model would be printed at 1:20 scale and displayed in Cathedral as an informative reminder that we do know what we should be having and seeing on the outside of the chapel. Later, once the client wants to recreate the stone parapet in full, the 3D software model can be printed at a 1/4 scale in stone resin maquette. This maquette could be worked over by the stonemason to refine the arises, the undercuts and so forth, letter for letter. At that juncture, a sample stone would have to be removed from the chapel wall in order to be sure of the dimensions and the profile and the building in of the carrier blocks. Then the mason would enlarge the maquette on the 3 built-in sides to match the built-in dimensions for the blocks and to oversize them slightly. Then the reworked maquette with the full block modelling can be 3D scanned and the data prepared for CNC cutting, so that under the direct control and guidance of the stonemason, the blocks can be cut to within 1 millimetre or so of the intended putative finished surface. So finally the mason would complete the carving and redress the hidden planar facets, in other words the jointing surfaces of the block for building in order exactly to match the reconstruction required and to bring the surface of the stone to a worked traditional hand finish which weathers appropriately, whereas machine finished surfaces on stone weather quite differently. And so with thanks and acknowledgements to Sarah Mayfield at Pay with Spencer Hall, to CAD-Plan Services, to Linton Lasers Limited and WHD Microanalysis Consultants, to Viz 3D and John Jones's Gallery, and to Hugh Wedderburn, the carver. With that, I hope you have enjoyed these 6 specialist digital and analogue personalities collaborating on the protection of masonry from irrevocable loss. And thank you for your attention, and to repeat that we owe it to 8.2 billion people to use their energy and their labour to optimise a minimal use of generated power and to minimise the production and maintenance and repair and replacement of manufactured technologies.